All right, so I have to talk about 5G programmable networks after Henning's discussion about QoS and whether or not he believes 5G network slicing is something that'll work. So let me try to convince you that it will work, but maybe some differences in the way people are thinking about how to do that. First and foremost, when we talk about 5G, we have to talk about how's it being used, all right? And this is kind of a classic discussion of it. The massive machine type communication, the critical machine, the critical machine type communication, and enhanced mobile broadband categories. But when you think about those, what is the use cases that we're delivering within each of those categories? What are the people trying to accomplish in terms of those types of use cases? And when you think about it, it's the smart agriculture, it's the AR, VR, but then you have to also look at how do I deliver that, right? So I've got classifications of these uses, I've got description of what they're being used for, but then each of them have characteristics that must be accomplished in order for that service to be delivered. And that's what I want to talk about, is 5G being able to take those classifications and services and deliver them. All right, the way we do it is network slicing, okay? It is to address the business drivers, but if you look at it, you have to look in terms of, you know, that driver being mobile, whether or not the application has dependencies on latency, the availability of that service and the reliability of the service offering, as well as the intensity of the interaction and the volumes of data that's being driven. So when we look at each of these business drivers, we have to look about, you know, how is that need being delivered? Where do we actually get that programmability into the service in order to make sure that those requirements are addressed? And when you do that, making it so that it's flexible, fast, and actually make sure that you don't impact others when you do that. So one of the things we've been talking to within Ericsson is network slicing and distributed cloud go hand in hand with 5G. And the reason for that is because of those various requirements, you're going to have sites placed at different locations for delivering on those requirements. And you know, those requirements are not just the 5G network functions, but they also have to be married up with the application or the use case that we're trying to drive toward. So for example, in the case of the automotive, you know, you have connected car, you want the network function and the radio function to be very close to the car in order to get to the, you know, critical apps for them. And that might be more around the self-driving apps, for example. All right. When you start to move toward the center, you can have more latency, you get a little bit more scale. And what you are able to do then is address another set of use cases. So what we see is kind of the spectrum for each of our targets, having a set of VNFs and applications that may be close or may be far in order to deliver that service. They may be on edge sites, they might be in regional sites, or in the core. But when we look at that, you know, it's driven by network characteristics that are needed by those services. So for example, when you look at things closest to the application, it's usually, you know, the desire to make sure you have low latency, maybe a high volume of data required around that device, or that it needs intelligence in order to fulfill its operations. So you need to move that out closer to the edge. Conversely, you know, if you can pool the resource, you know, then you have a better use of the overall resources, and you can gain in terms of your overall OpEx and CapEx. Kind of an example of distributed cloud where you can make use of it for two use cases. For example, the robot on a smart factory floor, you need the data center at the edge. Well, what's that data center, you know, need to have? One is the radio access. Two is a user plane so that you can, you know, send the data somewhere. And then three is the application itself, you know, to make use of that data and run the robot. However, because you have radio access out there in that smart factory, you can also, you know, handle the mobile broadband case. Well, in that case, you still have the RAN, but now you're more dependent on the data center for the connectivity of that application, maybe to an IMS server in order to fulfill a voice. Okay, so depending on how you're using, you know, the network and the service you're delivering, will place those application servers and those network functions in either the edge or in central sites. However, one of the things that we have created with 5G Core is an explosion of network functions, right? And in doing so, create a bit of criticality for making sure we have automation of these functions. So if you look on the 4G side, we have kind of a rather simplistic access network. Then it would you know, have a gateway toward your internet, and you have a simple subscription, right? Now that we want to do more, we've actually decomposed the functions so that you have, you know, an access on-ramp controller, and you have a session controller, and you have user data. Well, all these have been decomposed so that you have APIs you can interact with, but in, you know, delivering some of those core services, you have to stack those up for the service that you wish to deliver. Now, one of the things I think becomes important in 5G is a couple of network functions in particular. The network resource function, which basically says what do you have, what states are they in, and you know, what's their utilization. So do I need more? You know, so do I need more AMFs? And where is that AMF? The network slicing selection function, that helps you, you know, decompose your network into where are those resources available to you. So it works very closely with the network resource function, which is really good for us in the sense that now that we know where things are, and we've got a mechanism by which we can define, you know, those use cases and describe a slice, we can take advantage of, you know, some level of automation from these, right? So some of the automation that, you know, gets supported by this is the registration of a new service, all right? The notification if a service fails, the upgrade of those services. So this network resource function becomes essential to your ability to know where the resources are and deliver those resources toward these use cases. One other thing that's offered with the 5G architecture, and 5G core architecture, is the network exposure. So now you also have a means by which you can communicate toward other application functions. And what that does is it allows you to add on, so to speak, to those services you have delivered. And what's the beauty about this is this gives you the APIs in which you can construct further services. Now, when we look at the automation to this, though, you have to have some overall orchestration across the patch. You know, services in the 4G world were relatively constrained to, a couple data centers, a few data centers, and it was treated more or less like a big monolithic set of functions together to deliver the mobile broadband service fundamentally. Okay. Now, as we talk about delivering on a series of services cutting across the network nodes, now you have to look at how do I coordinate that? How do I make sure that the different cloudlets, you might say, are visible to that user and that service? And why is that important? Because when we look at the slices, they have different demands, different needs. So for example, on the public transport slice, this is one where you may want to say, hey, I'm actually going to try and segment my network slightly, isolate it, make sure it's managed almost as if there was a full separate network, right? And when I do that, I'm going to dedicate certain functions to fulfill that role, right? So everything in that slice is now dedicated toward that user. However, I still have some, things that I can share, right? And if I look at subscription data, for example, and policy, I can share those across multiple network slices. So now I have the opportunity within my large central data center on the control plane to actually manage across the number of slices and use that resource more effectively. When I do that, I now have subscription control. Now, when I also have the opportunity to decide is where do I want my network functions to reside? Is it in the national data center, or do I want it at the local data center? So when I talk about the manufacturing slice, that manufacturing slice, because of maybe smart or smart factory, I want to make sure I have network functions out in that edge so that I can keep my factory running, have good responsiveness, and then also with this UPF, go to my local app that controls my controls of my factory. However, I also have users that are off the mobile broadband network that maybe are going to make use of the radio access there, and find myself working as just enhanced mobile broadband, but for a certain class of users. So they're making use of the national network functions. Okay, so with this, it creates complexity, but once you define the slice, that's actually where the complexity ends. You've got now a service that's end to end, and you can put users onto that service. Okay, and give you a couple examples of creating that service. Here's where you have to have orchestration come back into play. So one of the things I will warn people on is you can't do 5G network functions without some plan of orchestrating those network functions. All right. And when you do that, what you're going to set up is I have a definition of what my service is going to be. That's one. Two, my VNFs have to be instantiated. Three, I have to decide where that is. So in this case, it's cluster 1. And 4, what are the functions that are going to exist in that site, right? So that's all orchestration. That's basically taking a template of what that network service is going to be, deciding where those network functions lie, and putting them into service. And 5, completing the picture, because I, as an operator, have this network slice. I have to make sure that those users are users authorized for that system. Right? So take care of some shared network functions back at the ranch. Okay. The enhanced mobile broadband slice. So again, I defined the slice. Now I have a shared AMF, or access management function. That's already up and running. 3, now I decide what else has to go with that. So that's the enhanced mobile broadband slice at a VCP edge site, right? So I'm bringing up a user plane, I'm bringing up a session management function, and then finally completing that slice with some shared network functions, for managing the subscribers. And then finally, my massive IoT slice, this being a transport scenario, I'm out at the edge, and again, defined the service such that I'm going to share the access. I'm going to now instantiate in another edge site my user plane and session for the massive IoT function, and then put those users into the system as well. So you can see, by using some logic here, describing a set of services that I want to fulfill, architecting and organizing your network functions to be placed to fulfill those services, and then wrapping it up with the orchestration, you can make this a programmable network. Right? So now what you have is the opportunity to add more users into each of these slices. So I think what we have the opportunity to do with moving this this forward is to take and extremely program how we're implementing the life cycle of VNFs, the slice management of those network functions, and then simplify the implementation for services toward the users. Right? So 5G has that promise. I don't think of 5G as working toward a specific QoS. I see it more as constructing a service and a set of conditions, so that service can be fulfilled. All right. So the opportunity that comes for the service providers is not just simply mobile broadband, but now I start to address new use cases. Now, I think when we kind of take this example of the network slicing for railways, you're going to start asking the question, who's providing that service? I think there's a lot of debate on how these will actually end up being realized. Right now, we've talked about 5G mainly being delivered by the service provider in the sense that they've got the spectrum, the RAN, and the core network is usually theirs, right? But we're starting to see some very interesting things happen where, you talk about private LTE. Well, do you sell the box and, that box is served by that user, and you provide some other level of services back at the service provider? So I think the story is still out on, where is this best served, how is it served, and then also the constellation of, I'll call it cooperators to deliver on that service. I kind of almost relate this toward the PBX business, where enterprises wanted to have control. They would buy these PBX systems, but you still had to have interconnections with the operators, right, in order to actually fulfill your business needs, right? So now, what's that parallel? Well, now I've untethered myself. I still have a lot of the same, desires to have a closed user group that's just my company. I have a desire to make sure that it interacts with my systems. So is the solution, carried fully by the operator? Is it carried in the public cloud? Or is it carried in the edge by myself, right? And I think that, one of the things that we have the opportunity to do with 5G is all these network interfaces are now defined. And what we have to figure out is the constellation of people who deliver on those services, or companies that deliver on those services. What it'll still require, though, is a close cooperation and some level, higher level orchestration between the groups in order to deliver on that. Okay. The example here on the slicing for railways have a lot of real estate. A lot of times they control their own radio access. They build their own private radios for the most part. Is the cooperation such that in order to deliver to mobile broadband users who are on that rail, that I let the rail company run that slice, in essence, right? For them, the benefit is they've got control of their systems. For the users of their service, they get access to radio networks. For me, as a radio supplier or mobile supplier, my users are taking advantage of that infrastructure and getting their service. All right, so there's kind of a win-win here. And I think the story's out on how these 5G networks come together. Now, when that happens, this is kind of the piece of the puzzle that has to be solved. Where's the automation across multiple domains? And how do those domains talk to each other? So, for example, in the way we've classically defined 5G, we have a level of service orchestration that tells the management systems, what needs to happen for those network functions. It works with cloud orchestration that says, I'm going to have, this network function in this particular cloud and report back to the EMS that it's up and running. All right. I also need this service orchestration, though, to communicate with my network and the WAN to orchestrate how these things connect together. So that work is where the real rubber lies, in that building the orchestration systems to support the network functions is going to be the key piece to making 5G successful here. Okay. So with that, that's where we're at. All right. So
very good. Question?
I didn't tackle the Henning question. Will 5G network slicing solve all evil? I don't think so. But I think.
Well, you are offering artisanal, handcrafted network slicing, aren't you?
I like that word. That was a good one from Dean.
If I'm an enterprise, why do I using, and it doesn't matter if it's public or private 5G, why do I want to go through a core network at all? Why don't I just get local breakout at the radio straight to the nearest fiber or MPLS or SD-WAN provider, the same way I do for my fixed connections?
You could. Now you're an island, though, right? So the promise I think the operators end up having is, okay, yeah, inside the island you're good, but now I don't have any other phone but my mobile, and now I have, as a user of a service provider, access to the whole world, so to speak, for my
But I get that in it as well. So basically, what I want is have taking your railway example or the port on the first slide.
Yeah.
I want to have cell tower there, and at the base of the cell tower, I want local breakout to the nearest fiber, because the same way I run my WAN for everything else is basically this is the entry point to the WAN, and I don't want the core network gets in the way. It's fine for the carrier wants a core network because it needs to manage its own resources. Yeah. But if I'm using fiber and MPLS doesn't come with a core. Why do I need this thing?
Yeah, you might not. I mean, as a user, maybe what you've decided is, I've got all my other access, and all my other resources separated up on the public cloud, and I'm going to just use CBRS and fulfill most of my needs. Anytime I'm, so to speak, in the net, in the wild, I just use my Wi-Fi connection, and I come back into my network needs. That could be very acceptable to some users. I mean, others it's not. So I'm not saying this is going to be a panacea for that. I think what it offers the opportunity is to reconstruct the networks so that it addresses what the enterprises are wanting. I think there's going to be use cases where it says, I actually do need a centralized core. I do need to connect with others, and therefore that's the role that the service provider provides, right? So, I think that there's still a lot of discussion about how do these things get realized. I mean, Nokia said very clearly they were going to go right after enterprises with radio access in the core, right? And why was that? Covering their bets, right? We're trying, in Ericsson, we've focused a lot more on the service provider. I'm not sure where the chips are going to lie with 5G yet. I mean, I still think there's a lot of discovery that's going to occur as we go through this. And part of that discovery is, here's another case, the hospital, right? Usually they have, some level of wireless system. All their systems are connected into that. Okay, do I need the service provider network for that? Maybe not. Maybe I do, in the sense that when doctors are, on call, I need to be able to reach them, right? Maybe that's the slice that you worry about. Is just when I'm outside the walls of the hospital, to get the on call for the doctor. That's a very small slice that is carried by them. I don't know how these confederations are going to work yet. I think the promise of the 5G architecture is to actually be able to plug in different solutions, and I think one of the things that are going to come out of this is there's going to be blueprints, things that seem to work really well together. There's going to be some things that are going to be very niche. This is unique to my situation. But I think the architecture has the opportunity to be able to address multiple needs. Okay.
With network slicing, is it important with interoperability between, when you have multiple operators, is there a need for then orchestration?
That's the piece that's really been undone here, right? In the 5G core, there's a lot of a lot of definition of what happens between these boxes here, right? But there really hasn't been clarity about, what happens when I go away from my network, right?
So your hospital connecting to the doctor, if the doctor is bringing
Going.
a device and it's on a different carrier,
Yeah.
doesn't work.
No.
Then you're not going to use that doctor,
Yeah. I mean, yeah. So, the bring your own device is an interesting scenario too, right? Because now, what network am I on, right? So, yeah. I mean, it's going to tear apart some use cases and maybe reconfigure the way people are operating. That'll be a lot of, how do I take advantage of multiple networks? Yeah.
So one of the questions I had, especially in the manufacturing case, when we start to look at the edge of the network slice, we have to get out onto a radio somewhere.
Yeah.
And so we're showing shared radio, which implies that there's other traffic running on that radio network. We're going to have adequate coverage. How are we going to guarantee access to enough of that radio service to supply that business case? In other words, I know there's the concept of RAN slicing. It hasn't really been implemented.
Correct.
And a lot of this is going to reside in the scheduler, which tends to be a rather closed interface depending on,
I think this
how
might
do we
run
do
back
this?
to the QoS discussion.
Yeah, it does run into the QoS.
A lot of those mechanisms are very hard to implement, especially on a shared resource like RAN, right? Yes, there's ways you can bar access. That may be it. You're dedicating that radio to purely the user. Sharing the resource and trying to bump priority, that's always going to be a challenge.
Any other questions? Very good. Thank you so much, Kelly.
Okay.